What up, everybody? Today we're going to be talking about complex circuits. And complex circuits can be complex, right? They don't follow the rules of series exactly or parallel exactly. I'm going to use this circuit to and the tools that I use to solve for the voltage and current in this circuit can be used for any complex circuit. All right. Now I'm also going to be doing a video on this circuit right here. All right, so let's just looking at both of those. And if you need help on complex circuits. And I'll also be doing another video where I do a circuit diagram and I solve it just by on paper and pencil. Right, and you can take a look at that as well. Right, but we're going to look at this circuit and I'm going to show you step by step how to solve a complex circuit. So stay tuned. All right, so where do we begin on this circuit? Well, there's a toolkit that you have when solving for any circuit, trying to find the current and voltage and that type of thing. And those tools are, the junction rule, the loop rule, combining resistors, and Ohm's law. V equals IR if you're looking for voltage. And then if you're looking for resistance or current, you'd use another form of it. But with these tools, you could solve any circuit, regardless of how simple or complex. And we have videos that we'll be posting on all these tools. So check out those videos if you need more help. But let's look at this circuit. The current is going to come out of the battery and it comes up to a split in the road, if you will. And that's what we call a junction. And so we're going to use a junction rule. The junction rule simply says that the current going into a junction equals the current going out. So the current going in we label as IT, T for total, and we call things that happen near the power source, near the battery, as total. And then it splits up into I1, which is a current that's going to go through this light bulb, and then I2, which is a current that goes through this light bulb. So that gives us this equation, and I'm just going to leave this equation up here, right? Because that's anytime you get an equation, you want to kind of write it down and look out because it might be important for finding something later on down the line. Anyways, the current will go in these loops. It comes back together down here at this junction. And so at this point, it's the total current equals current 1 and current 2. So essentially, it's the same equation. All right, so we'll just keep one of those on the screen. All right, so we just got that so far. That's not much. All right, let's look at the loop rule, which is our next tool. And the loop rule says that the voltage supplied by the power source, in this case the battery, is equal to the voltage drop across the resistors in a loop. Now there's two loops in this circuit. There's one loop there in green and another there in blue, right? You see that? And so let's look at the one in green first. The battery supplies 120 volts, which means that these two light bulbs have to drop 120 volts in total, right? So the voltage of light bulb 1 is what we're calling this, plus light bulb 2 has to equal 120, right? And so that's another equation. We're going to just leave it up there because it might become useful later. Now, good question. Does V1 equal V2? Do these two light bulbs have the same voltage? The answer is no, right? Even though they're both 40 ohms, they have different current going through them, so they're going to have different voltages. Now, going on to our second loop, the blue loop here, this light bulb and this light bulb are both on it, all right? So the battery supplies 120 volts. These two light bulbs put together have to add up to 120, all right? So that gives us this equation here. And we're just going to leave that on the screen. All right, so now we're kind of stuck because we don't know how much current goes down here through the second light bulb, and we don't know how much goes to the third light bulb. And we don't even know how much goes to the first light bulb. So we don't know the current anywhere. All right, and if this was a series circuit, we could just add the light bulbs in series. If it was a parallel, we'd add them in parallel. But it's both, or it has aspects of both, so we can't do it that simple. But what we can do is add resistors. All right, and before we do, does V2 equal V3? Yes, all right, because the voltage drop. Because even though they're on different loops, the voltage, you can imagine if there's a current here, it has to go through either one of these. It can't go through both. So they don't share voltage, so they must have the same voltage. All right, but let's combine resistors, like I was saying. So we're going to combine these two. And if we combine these into one, we can treat this like a series circuit, which makes it a lot easier. All right, and so what we're doing, we're combining resistors, is we're just pretending like if you removed this part of the circuit and replaced it with a light bulb that had a resistance equivalent to the part you replaced, what would that resistance be? All right. And so if I did this, what resistance would I get there? And the way you would do this, because these are parallel to each other, right? The current can't go through both. Like if you like a car driving on this road, you would either go through one or the other. Okay, there's no way to go through both of them. All right, so that's parallel. And with parallel, you can't just say 40 plus 40. You have to do this equation. All right, and we have a video on parallel circuits, if you want to look at that. It will explain this. But the R1 and R2 are both 40, and so if you solve the equation 2 over 40, you get that the total resistance for this configuration is actually 20, right? And so we're just going to replace all this with one 20 ohm resistor like this, okay? Now you might say, hey, you just changed the whole circuit. Well, we didn't change this part. Okay, we did change this part. We didn't change this part, and that's going to help us a lot. And so you'll see how this helps in just a second. But this is now a series circuit, and so we can add these two together again because you have a 40 and a 20 in series with each other. That's just 40 plus 20 or 60. All right, so now we're pretending that this is a circuit with one light bulb. We have the voltage, all right? We have the resistance. Ohm's law says that we have two of the three. We can always find the third, right? So we have voltage and resistance. We can find the current using that one. Okay, so 120 divided by 60 gives us a current of 2 amps, okay? So where is the 2 amps? The 2 amps is going to go through this circuit, all right? And this allows us to figure out some stuff because voltage is equal to current times resistance. And now we have a current. So if you look at this top light bulb, we know that there's 2 amps coming through it. And so we do V equals IR. We know the resistance is 40. That says that that voltage is 80. All right. Now we'll do the same thing to our imaginary light bulb over here. All right. And this time it's 2 amps times 20. That gives us 40 volts. All right. And what that means is that between here and here, if you were to measure this with a voltmeter, it'd be 40 volts. Now going back to our original circuit, the real circuit, you see that these 2 points correspond to these 2 points here, right? And so we found that the voltage drop between these points is 40 volts, which means going back to our real circuit, the voltage drop across this light bulb is 40 and this light bulb is 40. All right, so we can use the voltage we found here to go back to the real circuit and say that's a voltage. Now, we found 2 amps earlier. All right, that was for an imaginary circuit. And so it's not 2 amps going through each of these 2 light bulbs. All right, there is 2 amps going through this one. But to find the current, we'll just use Ohm's law because we have voltage and resistance for all 3 of the light bulbs now. So let's just do that. Ohm's law says that current is equal to voltage divided by resistance. All right, we put the numbers in and then we solve those, divide those. All right, so the current going through the first one is 2 amps. It splits up. 1 amp comes down this way, 1 amp comes down this way. Right, so we solved for the voltage, current, and resistance through the whole thing. All right, very good. Now, how do we check our work? Right, which is always a good idea. Well, we have the junction rule and loop rule. So the junction rule said that the total current that came into this junction, which was 2 amps, should equal the current that went out. So that means 2 should equal 1 plus 1, which of course it does. All right, then the loop rules for this first loop, it should be 120, all right, given by the battery. This one, the first light bulb takes 80, the next one takes 40. 80 plus 40 is equal to 120, so that works. And then the second loop here, there's 80 volts again, and there's 40 volts here, so 80 plus 40 equals 120, which is given by the battery. And so it all checks out. Right, we solved it, we've checked it. If you want to see this done on a paper and pen, I have a video that I do just that. All right, same problem, but you're more likely to have to solve it like this in an assignment. So if you want to see me do that, go ahead and click on this link and watch that. All right, if not, I'll see you all in another video.